Right, how are you? How are you? My name is Se Marashanye, and today we are on chemistry section, particularly on matter. So I'm going to do question and answer session, and I will give a little bit of explanations where there is necessary. Please, after watching this video, don't forget to like and to subscribe to our YouTube channel. Thank you. This is Combined Science. As you can see right now, this is Combined Science 2021 revision, chemistry online lessons with Mr. Marashanye. We are located on Budiriro 1, stand number which is 2005. Harare, Zimbabwe. For more information, this is our contact. You can call us on this network number, or you can WhatsApp on this number. Meta question and answer session. So this first question is saying define an atom. Define an atom. So let me explain something on atoms. So as you can see, let me first explain matter. Matter first. Matter. What is matter? Is anything that occupy space. Anything that occupies space, or we can say anything that is mass and a volume. Anything that is a mass and a volume. Right, this is very clear. So let me explain something here. This is from our syllabus, but it's important when we want to talk about atoms. So matter being anything that is mass and a volume, or being anything that occupies space. Matter can be found in 3 states. So there are 3 states of matter, which is 1, there are solids. There are also 2 liquids. Number 3, there are gases. Right, these are 3 forms that we can find matter. We have solid materials, which is matter. We have liquids. We have gases. So I'm going to explain more about this. Right, solids, these are things that are tangible. Liquid, these are the things like water, and gases, those are things like carbon dioxide and stuff like that. Those are gases. Right, matter being anything that occupies space. So I'm going to explain now what is an atom. So an atom, as this definition illustrates, it says an atom is a smallest particle of matter that can take part in any chemical reaction. This is very correct. An atom is the smallest particle of matter that can take part in any chemical reaction, which means matter is anything that has mass and a volume. Matter is anything that has mass and a volume. But in anything that has mass and a volume, there is a smallest particle in that matter. There is a smallest particle. There is something which is very smallest. And that thing is called an atom. And that thing must take part in a chemical reaction. So in simple terms, I'm saying atom ndicho chidiki pameta. Chinhu chidiki pane zvinhu zvese zvinokwanisa kuoccupy space, pane zvinhu zvese zvine mass, pane zvinhu zvese zvine volume. The smallest part is called an atom. I think you are assisted for question number 1. Let us move on to question number 2. It says, give any 3 subatomic particles and their relative charges. 3 subatomic particles and their relative charges. Right, we discovered that an atom is the smallest particle of matter. But on top of that, it is very important to know that what compounds or what subatomic particles that make up matter, which means that make up the smallest particle of matter. So what are those three subatomic particles? We have number one, we have what we call protons. And protons, they are well known for having a positive charge of +1. Then number two, we have electrons. As you can see, electrons, they have a negative charge, which means the relative charge for electrons is negative charge, which is -1. And the relative charge for protons is positive charge, which is +1. So proton is a subatomic particle. Electron is a subatomic particle, but the relative charge for protons are called positive charge, which is +1, and the relative charge for electrons is negative charge, which is -1, and the last one is called neutrons. Neutrons is one of the subatomic particles, and its charge is 0 charge or 0. I think you are assisted. Subatomic particles, these are the particles that make up matter. What is matter? Matter is the smallest particle. Matter is anything that has mass and a volume. And an atom is the smallest particle of matter that can take part in any chemical reaction. And subatomic particles, these are particles that make up atom. These are particles that make up what? An atom. And what is an atom? An atom is the smallest particle of matter that can take part in a chemical reaction. And matter, we said matter is anything that can occupy space. Anything that has mass and a volume. I think you assisted there. Let us move on the next question, which says why an atom is said to be electrically neutral. Why an atom is said to be electrically neutral. This question is very simple. This question is very simple. I'm going to show you how we solve this one. Right. Protons, they have +1 charge. Electrons, they have -1 charge. So the question is, why an atom is said to be electrically neutral? Then I am showing neutrons, they have a 0 charge. The question is saying why these are particles that make up an atom. These are particles that make up an atom. So what the question is saying, when the question is saying what are the subatomic particles that make up matter, these are subatomic particles and their relative charge. And the question going further and say why this atom? This is an atom because these are the particles that make up an atom, which means this is the what? The atom. So the question is saying why an atom is said to be electrically neutral. The question is very simply saying why the overall charge of an atom is always 0. Why the overall charge of an atom is always 0. The answer is very simple. Because the number of protons, which is +1, is balanced with the number of electrons, which is -1. So if you say 1 minus 1, we get 0. And 0 is a charge for neutrons. That's why an atom is said to be electrically neutral, because the number of protons is balanced with the number of electrons. This is the answer. Then the next question, which is number 4. It says, why protons and neutrons, sometimes called nucleons? Why protons and neutrons, sometimes called nucleons? I'm going to answer this question after answering question number 5, which says, draw a simple diagram of the structure of an atom. A simple diagram for the structure of an atom. Right, this is the structure of an atom. As you can see, we have this part. yepakati, which is called the nucleus, and inside the nucleus kureva kuti mukati menucleus mune maprotons, mune maneutrons. Kureva kuti maprotons and neutrons, this is the structure of an atom. Maprotons nemaneutrons, they are both found on the nucleus. And because of that, some scientists, they call protons and neutrons nucleons. Right, this line, this is the shell, this one, this is the shell, and this is called electron shell. Electron shell. Why it is called electron shell? Because this is where electrons are going to be arranged, are going to be placed. Kurwa ndo munosvika muchigara ma-electrons. Ma-electrons tati ane negative charge. As you can see, urikuona kuti panapa ndakaisa ma-negative, ndikaisa futi ma-negative apa. Saka zviri kureva kuti ndo munogara ma-electrons. Nekudaro anonzi ma-electron shells. And this one are called electrons. This is the structure of an atom. So question number 4 is why protons and neutrons, sometimes called nucleus? Because they are both found in the nucleus. That is the reason why they are called nucleons. Right? Let us go to number 6. Let us go to number 6. This is very simple. It says potassium has a mass number of 39 and an atomic number of 39. How many neutrons are there in one atom of potassium? How many neutrons there in one atom? Right, first of all, you must know that mass number, which is this one, mass number is equal to number of protons, which is an atomic number, plus number of neutrons. So tikaeda isusu number of protons plus number of neutrons tinofanirwa kuwana mass number. Then we substitute from the question. Tichaona takapuwa mass number from the question, tine atomic number again, then to substitute. Ndo patiri kuti then substitute. Kana ta substitute toona kuti saka number of neutrons anenge ari mangani. Right, panapa pari kubuda kuti number of protons dzinogona kushedza chinzi the atomic number. Number of protons ndo the atomic number. Zvakangofana ngoti atomic number. So tika substitute, tikasvika tikaisa mass number pane mass, tosvika toisawo the number of protons or atomic number painofana kuenda, which is here, which is 19, plus n yakamirira number of neutrons. Right, tapedza kudaro, then we collect like terms. Kureva kuti kucollecta ma like term takutora zvinokwanisa kuedheka zvakafanana. For example, tina 39 na 19 anokwanisa kuedheka kana kusubtracta. Ndo atinoti ma like terms. Ndo saka panapa pakanzi then collect like terms, then it becomes 39 minus 19. So the same concept atinongoshandisa kumaths, which says change side, change sign. Change side, change sign. Kureva kuti 19 ndi plus 19 akabva uko akaenda uko anosvika achita minus 19. So kuenenge yava 39 minus 19, they equal to number of neutrons. Then number of neutrons is equal to 20 neutrons of potassium. This is our answer. Right, the next question, it says, what is an isotope? What is an isotope? Right, I'm going to give a definition which is different from the marking scheme. Right, it says, pandakanyora this one, ndakati nini, are atoms of the same element with a different number of neutrons. But in some terms we are saying isotopes are atoms with the same element, which means it can be carbon. But the difference is on the mass number and on the number of neutrons. That is an isotope. An isotope is an atom with same number of protons, but different neutron and mass number. Same number of protons, but different number of neutrons and mass number. Let me go to question A so that you can understand isotopes. The question A says, draw the nuclide notation for carbon-14. Draw the nuclide notation for carbon-14. Right. Nuclide notation, first you draw the symbol, the atomic symbol for carbon, which is a big C. The atomic symbol for carbon, which is a C here. This is the atomic symbol for carbon. It's a C. Then kumsoro kunoenda inonzi mass number. Then kuno kuzasi uku kunoenda inonzi proton number or atomic number. Kuzasi kunoenda proton number or atomic. This is a nuclide notation. Right. So I'm going to demonstrate the isotopes of carbon. We have three types of isotopes of carbon. Number one, we have carbon 12. We have carbon 13. And we have carbon 14. These are isotopes. Why they are isotopes? Because the element symbol is the same. It's C, it's C, it's C. But the difference, as you can see, is on the mass number. So, because of that, carbon is an isotope. So I'm going to draw I'm going to draw the nuclide notation for each carbon. The number of protons of carbon atom is always 6. So I'm going to draw the nuclide notation for the first one. We have carbon 12. So 12 is our mass number. Then we'll put 12 here. Then here we put our atomic number, which is 6, atomic or proton number. And this is our element symbol. This is our element symbol. Right. Then I'm going to draw another one. Nuclide notation for carbon 13 now. Put 13 here. This is our mass number. Then 6 here. Right. This is element symbol again. Let me write ES. Right. I draw carbon 12, carbon 14. The atomic number is always 6. And this is our element symbol. Alright, this is very simple. Right, as you can see, we have an isotope of carbon with three different types of atoms. We have carbon 12, we have carbon 13, we have carbon 14. But check very closely. This is the mass number. The mass number for carbon 12 is 12. And the mass number for carbon 13 is 13. The mass number for carbon 14 is 14. Which means an isotope has the same number of protons, 6, 6, 6. But the difference is on the mass number. We have 12, we have 13, we have 14. The difference is only on mass number. But the atomic number is always the same. And the neutron number is different. That is an isotope. So in simple terms, an isotope is an atom with same number of protons. Same number of protons, but different mass number, but different mass number, but different mass number. And also different neutron number. That is an isotope. I think you are assisted there. Let us move to our next question. Our next question, it says, draw the electronic configuration for carbon. Draw the electronic configuration for carbon. Right, I'm going to explain what is electronic configuration for carbon. Right. Electronic configuration for carbon, electronic configure. Right? What is it? Is the arrangement of electrons in shells. The arrangement of electrons in shells or electron shells. Saka electronic configuration, in simple terms I'm saying, kurongedzwa kwema electrons. But ma electrons anorongedzwa muma shells or electron shells. Iyoyo yatetaita ndo inonzi electronic configuration. The arrangement of electrons in electron shells or in shells or in orbitals or in energy levels. That is electronic configuration. Kurongedzwa kwema electrons muma electron shells. So let us look at our question. The question is saying for carbon is only 6 electrons, which means the number of electrons is this, or the number of electrons of an atom is the same as the number of protons. Because in the periodic table, you find out that what is written on the periodic table is only the proton number. So how do you calculate the number of what? Of electrons. Just to know that the number of electrons is the same as the number of protons. So ukaenda pa periodic table ukacheka iwo paine number of protons. Wakutozwa kuti number of protons iyoyo kuona hiyo ndio number of electrons. So pa carbon pane 6 protons, which means the carbon atom in a 6 electrons. So arrange those electrons in shells. How do you arrange? First, you have to know that the first shell must hold a maximum of 2 only. Kureva kuti pa first shell unofana kuisa 2 my electrons. Right. Pa zvinhu 6 kana kuti pa ma electrons 6 tikabvisa 2 tinosara nemangani? Tinosara ne 4. That's why pekutanga pa first shell panapa pakaiswa 2. Then the second shell pakazoiswa mango 4 ngaita sei asara. But ausiriwo mutemo we electronic configuration unotiwo. The first shell must hold a maximum of 2. The second shell must hold a maximum of 8. The third shell must hold the maximum of 8 again. The fourth shell must hold a maximum of 18. So, iwewe kana wene carbon yako, carbon ine 6 electrons. As you go to pa second shell wesa 18. It's not a problem. Iwe rongedza chete ma electrons e carbon in shells. Paano perera ndipapo. Saka usazoisa 8 uchiti kwa ndodoti azare. No. Apa nongosiya asina kuzara. It's not a problem. Right. I'm going to draw carbon. The electronic configuration for carbon. First, put an atomic symbol, which is C. Which is C. Then draw the first shell. This is the first shell. Right. Carbon. In a electrons mangani, in a 6 electrons. In a 6 electrons. Right. Pa 6 electrons. Kwanzi the first shell and draw. Rinofana kuzara ne mangani, ne 2. Ndo isa 2. Unogona isa ma dot or a cross. But then I used the cross. 1, 2. So pa first shell it's enough. And jafanda kuwedzera. The second shell rinozara ne mangani ne 8. But nindabvisa 2 pa carbon in a 6. So pandabvisa 2 pa carbon kwasara mangani kwasara 4. So which means pa second shell ndichangwesa mangani? Changwesa 4. Do aripo. So I put 1, 2, 3, 4. This is the electronic configuration for carbon. I think you are assisted. Right, for today, let us end here. Please don't forget to like and to subscribe. I thank you.